Hello everyone, my name is Sławomir Nowakowski. I'm a second tier support engineer at Open-E. I'd like to invite you to the webinar, which topic is ActiveActive versus ActivePassive cluster performance advantage. And today's webinar will be about how to set up ActivePassive cluster with Open-E DSS V7. And then I will show you how to switch from ActivePassive to ActiveActive cluster. And we will discuss performance advantages, and we will be check performance with the Iometer tool. The webinar will be recorded and will be available on the website, our website open-e.com. You can download it and watch later when you want. My setup is ActivePassive at the beginning. So I have two DSS servers configured ActivePassive. Each DSS has two virtual IPs. They are configured on ETH0 and ETH1 on DSS node A, and on the DSS node B there are ETH2 and ETH3. The virtual IP is 10.1221 and 11.21. Also, both nodes are connected over 10 gigabit interface. This interface is used for auxiliary 10-bit connections, and as well as for volume replication, which is a synchronous replication between nodes. I have also a Windows storage client, which has two interfaces configured for ESCazu connections, and those two interfaces are configured in 10.10 IP and 11.10 IP. Let me show you the configuration of DSS on the web GUI. So currently I have ActivePassive server configured. Its running state is okay. I have one ping node set. I have two auxiliary paths, which are the requirements of the cluster at Open-E. There must be at least two auxiliary paths. There can be more if you want. And default failover IO triggering policy, which trigger failover in case of any IO errors related to your storage. Due to fact I have an ActivePassive cluster, I have only one resource where I have configured two ESCazu targets, and also I have two virtual IP addresses. This is due to fact I will use the MPIO feature during this webinar. I have two ESCazu volumes that are configured in volume application. As mentioned before, the volume application runs over a 10 gigabit interface. This is what we suggest to use for volume replication. This is due to fact that volume replication is synchronous replication, which means that local I/O write is only done when the I/O is written to the primary and to the secondary node. So in case the connection between nodes will be slow, for example, you will have 1 gigabit connection only, the local write performance will be limited to the performance of the replication connection. That's why we suggest to use a 10 gigabit interface. This is this interface here, or you may use balance RR. It's a bonding balance round robin. With, I think, at least 4 interfaces should be enough in most of the purposes. With balancer R and 4 gigabit interfaces, you may reach something near to 400 megabytes per second, which is quite good. Okay, so I have two volumes. Both are set at source on my node A, and on node B, both are set to the destination. I have also, as mentioned before, two ESCazu targets. One is target 0. Each target consists only one loon. This is due to performance because all parameters related to ESCazu, like QDepth, like max receive and send segment length, are per target, not per volume. So in case you want to achieve the best performance and the less latency, you should have configured only one volume per each target. Okay, so at this stage I have ActivePassive server cluster already running, and I can connect to my ESCazu resources. In ESCazu my ESCazu initiator is already configured in MPIO, so I have for each ESCazu target 2 sessions, 2 paths. Each is active, and I may check it. If I go to the disk management and go to properties, I have an MPIO tab. I can see that I have 2 paths, each is active and optimized, and my current MPIO policy is round robin. You may also switch here to other MPIO policies, but we do recommend to use the round robin due to fact it is load balance and high availability policy. So in this case gives you advantages in case of any link failures, as well as advantages in performance. So I have already prepared some Iometer testing procedures. I have stored, I will show you what exactly is said. So I have 4 workers. It is due to the fact that my Windows machine has 4 cores. Number of outstanding IOs is set to 8 for all workers. The first worker and the second one uses the physical drive 2, which in this case is my ESCazu target 0. This is this one, and worker 3 and 4 uses physical drive 3, which is my ESCazu target 1. Okay, I have prepared 2 tests. One is sequential write. Sequential write is with 1 megabyte block size. Stop 100% write and 100% sequential. So if I go to result display, I may start the tests. So I'm now checking the performance of ActivePassive cluster with 2 ESCazu targets. As you can see, the performance, the write performance is near to 150 megabytes. 160, it's not constant. Let's wait a while. Okay, it will be 160. So we will store our results. And now we will check the read performance. read performance is of course better than write, and we can achieve up to 230 megabytes around 225. Okay. So in ActivePassive cluster with two DSS V7s, in this configuration we could achieve 160 megabytes per second when writing, and 225 megabytes per second when reading. Okay, so now I will show you how to quickly and with less steps as possible move from ActivePassive cluster to ActiveActive. So the first thing we should do, I will stop the Iometer as well. The first thing we should do, we should disconnect from our ESCazu resources. It is due to fact that Windows caches some informations, and when we will reset up the systems, we can have some troubles to connect to those targets again. So the suggestion is to disconnect from our ESCazu resources. Now we need to stop the failover service. So we can do this in the setup failover tab and clicking on the stop button. It takes some time because some services are being stopped. Both nodes communicate each other during stopping and validating some other changes. It's not just force stopped, but it's gracefully shut down of the ESCazu cluster. Okay, my cluster has been stopped, so now I can go further to reconfigure my cluster from ActivePassive to ActiveActive cluster. What I need to do is to change the volume replication mode of at least one volume, or in case I would be creating new volumes, then set them in other way, but I want to show you how to switch from ActivePassive to ActiveActive when we have exactly the same storage as in both cases. So I had created two ESCazu tasks, ESCazu volume replication tasks. I need to stop at least one. In this case, I will use T1, B2A reverse tasks. After it is stopped, I need to switch here to destination mode. And on the second node, on the node B, I need to switch the volume replication mode to source. And when I'm ready, I may start the task. I can check the status of my task during starting. When it will start, it should show. Okay. My task has started successfully, and consistency is reported as consistent, so everything is fine. Okay, now I go back to the failover configuration. I need to create a new resource pool, but before I have to remove one of my ESCazu target from first resource pool. So In this case, it is my the target one will be the one I will switch to the other node. So I'm just removing it from resource pool on DSS node A. Okay, before I will go to configuration of the other resource pool, I'd like to show you some differences between ActivePassive and ActiveActive in my scenario. In both cases, we have the same storage and the same number or interfaces used in failover on both DSSs. The only differences is on the storage client, and in this case we have more interfaces on the storage client to be able to get them better performance, because our in case we would have only two network interfaces, which all are 1 gigabit interfaces, we could achieve something like 250 megabytes. So I used more in ActiveActive, because in this case the interface ESCazu 10 and ESCazu 11 will be using resources on node E, and if the interfaces ESCazu 12 and ESCazu 13 will be using resources on node B. So I go again to resource pool configuration, and I need to add ESCazu resource. And I need to add at least one virtual IP, but in case I want to use the MPIO feature, I need to put them all. I'd like to show you that on the node A resource pool, I'm using ETH0 on the local node and ETH2 on the remote node. And for the other virtual IP, I'm using ETH1 and ETH3. I will do almost the same for this configuration, but I will use different virtual IP. So my virtual IP here will be as per my picture. I will use here 12.21 and 13.21. And I will use exactly the same interfaces on both nodes. So as you can see here, it was ETH0 and ETH2. So I'm using the same interfaces, because I need to put net mask. And I need to add the other virtual IP. So now I use ETH1 on the local node and ETH3 on the remote node. The same like in this case. But my virtual IP here will be 13.21. Okay, my second virtual IP address has been configured. So I have two virtual IPs, and each resource pool has one ESCazu target. Now I'm ready to start the cluster. During the start of the cluster, I'd like to show you how to enable the MPIO feature on Windows. It requires some additional steps as well as reboot. So you go to Server Manager and go to Features, and you have here option Add Feature, and you just select Multipath IO, install, next, and so on, and MPIO will be installed. After that, you need to go to Administrative Tools and MPIO, and right now it's enabled for me, but you need to, before you enable it, you are able to add support for ESCazu devices. You need to select this checkbox, click on Add, and you need to reboot in order to the changes for take effect. So after we have the MPIO feature enabled and our cluster has been started also, we can now configure our ESCazu connections. Before, I need to add another portals for our ESCazu sessions. So I am adding portals of newly created virtual IPs. Okay, so now I can connect using Multipath to our ESCazu target. Sorry, I made a mistake. You need to select the target, go to Connect, click on Enable Multipath, and click on Advanced. And you are choosing local adapter. Initiator IP, you need to choose IP of the initiator, which will be used as source, and you need to choose the IP which will be used on the target side, which should be in the same subnet. What we strongly suggest to use each interface, even virtual IP interfaces, to be configured in different subnet. It's related to routing, and in case you will have more than one interface in the same subnet, you may face the routing issue, and even if you will try to ping one of the interface, the system may return over the different interface which is configured in the same subnet. So we always do suggest to configure all IPs to be in different subnets. Okay, one path is active. Now I go to Properties and add new session. This time I will use 11.10 and 11.21 on the target side. Okay, I have two sessions. The same I must do on the other target. In this case, this target is active on the node B, which has those virtual IPs configured. So I will use here 12. My mistake, I should refresh also. During discovery session, your targets are being exported, and you should refresh after making any changes, because only during discovery session your targets are listed on the initiator side. So sorry, I should use 12. It seems my ESCazu initiator has cached some information, so in order to remove those information, I can remove portals, this one and this one, and add them back. As you can see, now I should only see only one target here, so I am adding portals again. Oh, sorry, I made a mistake. I use 31 here and 21. I should use 21. That's why I can connect. So just a spelling mistake. I will use 31 here. Okay. But the other dual IP is 21. Okay. That's right. Can remove, and it's 1321. Okay, now it should be fine. Now I can see the target again. And go to connect, advanced Microsoft. I choose as a local adapter Microsoft ESCazu initiator, and in this case it will be my 20.10 and 20.31. Okay, and I need to add new session. And it will be 40, 13, and 13. Okay. So each ESCazu target has two active sessions, which we always can check, as mentioned before. Here, I will initialize both disk and go to properties. And there are two paths optimized to this volume, and the same for the other one. Okay, so my DSSs are configured in ActiveActive cluster, and the connection from a Microsoft system is configured over ESCazu. So now I can go and check the performance. Again, I have two workers on physical drive drive 2, which is the ESCazu target 0, which is active on the node A, and worker 3 and worker 4 are pointed to the physical drive 3, which is ESCazu target 1, which is active on node B. So I will check the write performance. Start. We'll wait a while to stabilize the performance. Okay, it's something like 270 or 80 megabytes per second. So as you can see, we used exactly the same hardware. We used everything on the DSS was not reconfigured. We used exactly the same number of interfaces on the DSS V7, and our write performances almost doubled, something like 800%. So now we will check the reading performance. As you can see, when reading also our performance is almost doubled. The only differences between our ActivePassive and ActiveActive configuration is that we used more ESCazu ports, more interfaces on the storage client, and we have almost doubled the performance doubled the performance. Okay, that's visually everything what I wanted to show you. If you have any questions, please use the chat, which can be found in the viewer panel, and I will try to answer all your questions. I may also invite you to our knowledge base website, where are many informations related to DSS V7, some troubleshooting and information. Also, which I would like to also invite you to watch other webinar on our website, which is related to the webinar I showed you today. It's about tuning the performance when you have a 10 gigabit interface for replication. Find it right now. Here is the webinar describing how to tune both systems to have less latency times and better performance when using 10 gigabit interfaces for volume replication. But this is also suitable for 1 gigabit interfaces configured with bonding. Okay, I can see that there are no other questions, so I'd like to thank you for attention. I invite you for our next webinars that are planned. The schedule can be found on our website. And have a good day. Bye.